Unit 10, Solutions. By the end of this unit, you will be able to use the solubility rules when conducting investigations with solutions, calculate the concentration in terms of molarity, accurately calculate and dilute a solution, distinguish between electrolytes and non-electrolyte solutions, distinguish between saturated, unsaturated, and supersaturated solutions, and explain the factors that influence solubility. Mixtures and solutions. What is a mixture? A mixture is a combination of two or more substances where each of the substances still retain their own properties. Heterogeneous mixtures are mixtures where two substances are not blended smoothly through the mixture. Think mud and water. A homogeneous mixture is one where the composition is the same all the way through. What is a solution? A solution is any homogeneous mixture. A solution is made of two parts. The solvent is the largest part. The solute are the smaller components. You can have more than one solute, but only one solvent. Types of solution. So a gas mixture, an example would be air. The solvent, the largest part, is nitrogen, and the solute would be oxygen and water vapor. A gas liquid example is sparkling water. The solvent is water. The solute, what is dissolved in it, would be carbon dioxide. A solid liquid solution would be like Kool-Aid. The solvent is water, and the solutes are sugar, food coloring, and flavoring. A liquid solid, one example would be an amalgam. The solvent is silver metal, and the solute is mercury. And the last type would be solid and solid. So like sterling silver. Silver would be the solvent, and usually copper is the solute. A substance that can dissolve in a solvent is called soluble. A substance that cannot be dissolved is insoluble in that solvent. Two liquids that are soluble in each other are miscible. Two liquids that can be mixed together but separate are immiscible. Quick check. Determine the solute and solvent in each of the following. So I'm going to underline the solute and circle the solvent. So the solvent is what you have the most of. So copper and brass and zinc would be the solute. Ocean water. Water is the solvent, and sodium chloride and magnesium would both be solutes. 18-karat gold. So what you have the most of is the solvent, so gold, and copper and silver are both solutes. What things influence solubility? Solubility is influenced by polarity, particle size, temperature, and pressure. How does polarity affect solubility? The polarity of a molecule determines what type of solutes can dissolve in it. Polar molecules will dissolve in other polar solvents. Nonpolar molecules will dissolve in nonpolar solvents. Water is a polar molecule and will interact with other polar substances. Remember, like dissolves like. How does particle size affect solubility? Smaller particles tend to be more soluble than larger molecules. How does pressure affect solubility? Gases dissolve more at higher pressure. Pressure doesn't affect solids or liquids. How does temperature affect solubility? Dissolving may require the breaking of chemical bonds. This means energy is required. Most solids will dissolve more when a solvent is warm. Gases are the opposite. Gases dissolve less at high temperatures. Compare the solubility of the following with less than, greater than, or equal to. So sucrose, which is a solid, would dissolve more at a higher temperature. So it would be greater at 75 degrees. CO2 is a gas, and they dissolve less at a higher temperature, so 11 degrees would be greater. NaCl is a solid, and pressure doesn't affect how much solids can dissolve. And O2 at 1 atmosphere would be greater than the solubility of oxygen at 0.52 atmospheres. Solubility rules. What are solubility rules? Solubility rules help you determine which substances are soluble in water and which ones are not. This is very important in reactions so you can determine what solid is produced. How are the rules organized? The solubility chart is organized mainly by anions. Anions are the negatively charged part of the compound. How do you use the solubility table? To use the solubility rules, find the anion that is in the compound, then check the exceptions for the cation in the compound. Quick check. Determine the solubility of each compound. HBr. So we'll find Br. It's normally soluble except for silver, lead, or mercury. So this one would be soluble. The next one, strontium sulfate. So we would find our sulfate ion and then check the exceptions. And strontium is one of the exceptions. So this one would be insoluble in water. The next one is silver chloride. So we find chlorine. Chlorine is normally soluble. So we check the exceptions. And silver is one of the exceptions. So it would be insoluble. And the last one, lead bromide. So bromine is normally soluble, but lead is one of the exceptions. So this one is also insoluble. What are solubility curves? Solubility curves show how the solubility of a substance changes with temperature. Solids will have a higher solubility at higher temperatures. Gases will have a lower solubility at higher temperatures. The curve typically shows the amount of solute that can dissolve in 100 grams of water at different temperatures. What does the solubility curve tell you? The line tells you that at a certain temperature, that is the maximum amount you can dissolve. Anything below the line makes an unsaturated solution. An amount above the line would be a supersaturated solution. Quick check. How many grams of KCl are soluble in 100 grams of water at 40 degrees Celsius? So we would find KCl and look at 40 degrees. So it would be about 38 grams. Which compound is the most soluble at 10 degrees Celsius? So we look at 10 degrees and which one is the highest at the top? So that would be sodium nitrate. How many grams of potassium chromate are soluble in 100 grams of water at 50 degrees? So we look at potassium chromate and 50 degrees. So that would be right at 30 grams. And how could you describe a solution of 31 grams of NaCl at 90 degrees? So at 90 degrees, 31 grams of NaCl, that would be an unsaturated solution. Determining the concentration of solutions. What is concentration? Concentration is the measure of the amount of solute that is dissolved in a specific amount of solvent. A solution that contains a lot of solute relative to the solvent is concentrated. A watered-down solution would be dilute. How do you express concentration? The concentration can be expressed several ways. The most common in chemistry are percent by mass, percent by volume, and molarity. What is molarity? Molarity is the moles of solute per liter of solution. What is percent by mass? Percent by mass is the mass of the solute divided by the mass of the total solution times 100. What is percent by volume? Percent by volume is the volume of the solute divided by the total volume of the solution times 100. What is the molarity of a solution that contains 40 grams of glucose in 2.5 liters of water? What is the molarity of a solution that contains 40 grams of glucose in 2.5 liters of water? So our first step is we need to find out how many moles are in 40 grams of glucose. So 1 mole of glucose is 180.156 grams. So our first step is to convert grams to moles. So we have 40 grams. We're going to divide by our molar mass, and we get 0.222 moles. Now we use our molarity formula. Molarity is equal to the moles divided by liters. We had 2.5 liters. So our molarity is 0.088 molar. Find the molarity of a 2.4 liter solution containing 2.5 grams of potassium bromide. So again, we need the molar mass of potassium bromide, and that is 119.002 grams. Our first step is to convert grams to moles. So we have 2.5 grams of KBr divided by the molar mass and 1 mole of KBr. So we have 0.0210 moles. Remember, our formula for molarity is moles divided by liters, and we had 2.4 liters. So molarity is equal to 0.00875 molar. What is the percent by mass of 13.2 grams of sodium chloride in 750 milliliters of water? So our first step is we need to know how many grams are in 750 milliliters of water. We know that the density of water is 1 gram per milliliter, so 750 milliliters is equal to 750 grams of water. So to find the percent by mass, we have the mass of the solute divided by the total mass times 100. So we have 13.2 grams divided by 750 plus the 13 grams, so 763.2 grams times 100. So our solution would be 1.73%. Solution preparation and dilutions. How do you make a solution? 1. Once you know the molarity and the amount of solution you need to make, determine the amount of moles that you need by using the formula molarity equals moles per liter. 2. Convert moles to grams. 3. Add the grams of solute that you need to the appropriately sized volumetric flask. 4. Fill the bulb of the volumetric flask. Place the lid on the flask and invert it to dissolve all of the solute. 6. Once the solute is completely dissolved, fill the flask to the line on the neck. 7. Invert the flask a few more times to mix the solution. How would you make a 0.1 molar solution of NaCl in 100 milliliters? So our first step is to figure out how many moles we need. So molarity is equal to moles per liter, so 0.1 molar is equal to moles over 0.100 liters. So we'll multiply each side by 0.100. And so moles is equal to 0.01 moles. So now we multiply by the molar mass of NaCl. So 1 mole of NaCl is equal to 58.44 grams. So we started with 0.01 moles times 58.44 grams, 0.5844 grams of sodium chloride. So we would add 0.584 grams of sodium chloride and enough water to make 100 milliliters. What affects the rate a solute dissolves? The rate that chemicals dissolve can be influenced by pressure, temperature, agitation, and surface area. How does temperature affect the solubility rate? Solids typically dissolve more quickly and in greater amounts with higher temperatures. Gases dissolve less at higher temperatures. How does pressure affect the solubility rate? Gases will dissolve faster under higher pressure. Pressure has no effect on solids or liquids. Agitation. Stirring or mixing a solute will increase the rate it dissolves. In surface area, solids that are broken up into smaller pieces will dissolve more quickly. Dilution. What is a dilution? A dilution is made when you have a concentrated solution and would like to make a more dilute solution. The formula is M1V1 equals M2V2. What is the concentration of an hydrochloric acid solution prepared by adding 45 milliliters of 12.2 molar HCl solution to 500 milliliters of water? So M1 is 12.2, V1 is 45 milliliters, M2 is what we're looking for, and V2 is the 500 plus the 45, so 545 milliliters. So we're going to use our formula, M1V1 equals M2V2. We plug in what we know. When we solve for M2, we get 1.00 molar. .45 liters of a 0.25 molar hydrochloric acid solution is diluted to a final volume of 2 liters. What is the new molarity of the solution? So V1 is 0.45, M1 is 0.25 molar, M2 is what we're looking for, and V2 is 2.0 liters. So we plug in to our formula, M1V1 equals M2V2. M1 is 0.25 times V1, 0.45 liters, is equal to M2 times V2. So when we solve for M2, we get 0.056 molar. Unsaturated, saturated, and supersaturated. How can we describe solutions? We can describe solutions as saturated, unsaturated, or supersaturated. What are unsaturated solutions? An unsaturated solution has a low concentration of solute. More solute can be dissolved when added. So compared to the volume of solvent, there's very little solute in an unsaturated solution. What are saturated solutions? A saturated solution contains the maximum amount of solute possible at a given temperature and pressure. No more solute will dissolve. Any solute added will sink to the bottom. What are supersaturated solutions? Solubility is affected by increasing the temperature. A supersaturated solution contains more solute than is normally possible in a saturated solution at the same temperature. To make a supersaturated solution, the solution is heated to increase the amount of solute that dissolves. The solution is then slowly cooled. This type of solution is very unstable. Crystallization can occur if a small amount of solute, a seed crystal, is added to the solution. Crystallization can also occur if the container is scratched or the solution is stirred or tapped. Solvation and dissociation. How do things dissolve? For a substance to dissolve, the intermolecular forces must be broken. This happens by solvation or dissociation. What is solvation? The surrounding of solute particles with solvent particles to form a solution is called solvation. In water, this is called hydration. The forces holding the molecules together are broken, but the forces between the atoms in a molecule are not broken. What is dissociation? Ionic compounds and acids break apart into ions. This is known as dissociation. What happens to ionic compounds with polyatomic ions? The polyatomic ions do not dissociate because they contain covalent bonds. Electrolytes and non-electrolytes. Pure water is a poor conductor of electricity. However, when ions dissolve in water, they are able to conduct electrical charges. These solutions are called electrolytes and are capable of conducting electricity. Ionic compounds and acids dissociate in water and are strong electrolytes. Polar molecules dissolve in water but do not form ions. Since these solutions are not conductive, they are non-electrolytes. In non-electrolytes, the solute exists as molecules only. Weak electrolytes exist as ions and compounds in a solution. They only partially dissociate. In strong electrolyte solutions, the solute exists as ions only. Water. What makes water special? Water is a polar molecule. The oxygen holds the electrons more closely, so it is slightly more negative. The hydrogens are both slightly positive. Since water is polar, it is able to interact with other polar molecules. Remember, like dissolves like. The positive regions in the water molecule are attracted to the negative regions in other molecules. Water can dissolve most substances. This is why water is called the universal solvent. The polarity of water is so strong that the hydrogen atoms of one molecule will attract the oxygen atoms of another molecule. This is called hydrogen bonding. This gives water many of its unique properties. Water is cohesive. The water molecules stick together. This is why water has surface tension and forms drops on smooth surfaces. Adhesion is the force of attraction between water and other polar molecules. Because of the attraction between the water molecules and the glass in a graduated cylinder, we see a meniscus. Water is also one of the only liquids that expands when it freezes. Due to the hydrogen bonding, water molecules freeze with all positives facing negatives. This means that there is an empty space in the solid state that are not present in liquid water. This is why ice floats. What is hydrogen bonding? Hydrogen bonding happens when a slightly positive hydrogen atom in one molecule is attracted to a highly electronegative atom in another molecule. Hydrogen bonds are an important intermolecular force.